Hello everyone. In this module of the lecture Basic Electrical Engineering, I'm going to discuss about the different elements used in basic electrical engineering like active element, passive element, unidirectional element and bidirectional element. These are our topic which I have to discuss. So before going to that topic, the book which I follow for this lecture is Basic Electrical Engineering by D.P. Kothari and I.J. Nagarath is IIT retired professor D.P. Kothari. And another book that I will follow, that is same title, Basic Electrical Engineering by Fitzgerald, A.E. Fitzgerald. These two books I will follow. For theoretical point of view, I will consider this book mostly, and numerical I will take from the D.P. Kothari book. This book is published by McGraw-Hill Publisher. McGraw-Hill Publisher. McGraw-Hill Publisher. So this topic will be governed by using this book. So in basic electrical engineering, mostly we are encountered with the five type of element which you have already seen in your class 12 also. This element will be discussed in detail, like active, what is active element, what is passive element, what is unidirectional element, and what are bidirectional element that we have to study in this lecture. So let us start with the topic which I have shown here is the component which we use in basic electrical engineering as given here is resistor. So resistor symbol is like this. Capacitor and inductor. Only these three elements will be used in basic electrical engineering. And symbol of capacitor, you also know it from your 12th class. The inductor symbol is like this. So these elements, and this is the symbol for variable resistance. Its symbol may be like this also. Its symbol may be like this also, variable resistance. This is transistor. It has three terminals, base, anode, and cathode. Three terminals are there, and diode. So these elements which takes energy, these elements are called passive element. Passive element. Passive element means the element which takes energy from the source and it either dissipated in the form of heat as the case of the resistor, or it stores the energy as the case of capacitor and inductor, and when needed it releases that energy. So this is called passive element. Passive element means those elements which are taking the energy, and it's those type of element which are taking the energy as resistor. It takes energy and it losses in the form of heat. It is also passive element. Capacitor takes energy, store energy in the electrical field, and when needed it releases that energy. Inductor same, it also stores the energy in magnetic field, and when required it releases its energy also. So the energy is half Li square, and in capacitor half CVA square. This is the energy when capacitor takes, and when required it releases. So these are the elements which are known as passive element. And active element are also part. Active elements are those element. Active elements are those element those element which gives energy, which gives energy, like voltage source, voltage source, current source, means which giving energy, not taking energy and wasting. It's just supplying the energy. So this type of element is called active element, and this element is very useful for electrical point of view. Now certain symbols are given here which have already encountered in your class 12, like resistance, it is denoted by this symbol, a unit is ohm, and capacitance, this is the capacitor, and it's given by symbol is C, and it is measured in farad, but farad is very big unit, so we use generally it is given in microfarad or nanofarad, like that. Inductor, its symbol is like this, and it is represented by L, and its unit is Henry. So only these three elements we have to study in basic electrical engineering, like resistance, capacitance, and inductor. These three elements we have to study, only three elements, and two more sources like voltage source, it is generally denoted like this, and current source, it is denoted like this. So only these five type of element we will have to study in basic electrical engineering. Only these five type of. And equation, this is the equation for resistance, it is from Ohm's law, V by I will explain everything just based on the Ohm's law, V equal to IR, in the coming lecture, that will be done based on the certain analysis, certain law we will have to study. So this law we will be very frequently we will be using, that is V equal to I into R Ohm's law. And this capacitance, C is, it is, you have already studied this thing, it is Q by V. It is the ratio of Q by V. And for, if you increase the Q, if increase Q, V will also increase, so that this C remains constant. C does not change. If someone asks you if increasing the charge, does capacitance increase? No, capacitance will not increase. If we increase the charge, the voltage will increase also, and so the ratio remains the constant. And the form of inductor, that its inductance L is given by VL by di by dt. It is that rate of change of current, that we will study all this thing in very detail in coming lectures. We will study this thing in detail in the coming lecture, but for this time I am just showing its importance. Okay, this is the inductor, and VL equal to, from this relation we can also write VL equal to L d I by dt. When there is a change of current, then voltage will be produced in the inductor. That inductor is given by VL equal to LD by dt. And this is the series connection, RT. If two resistances are in series, R1 plus R2 will be the total resistance. And in capacitance, if they are connected in series, their equivalent will be 1 by C, equivalent equal to 1 by C1 plus 1 by C2. And for inductor, it is same as the resistor. But for parallel combination, the resistance is 1 by RT, 1 by R1 plus 1 by R2. And in capacitance, it is equal to CT, which is equal to C1 plus C2 if capacitors are connected in parallel. And if inductors are connected in parallel, it's same following the rule of the resistance. As here, we can see this and this, it is the same form of grouping like in series and in parallel of the inductor and inductor and the resistance. Capacitor has inverse relation with respect to the resistance. Now certain thing we have also to go for the calculation point of view, that is, one thing is called ideal current and voltage source. What is ideal current source and what is ideal voltage source? You see here, this is an example of uh, ideal current source I am drawing here. This is also called independent source. Independent current source. This is also known as independent current source. Its symbol is like this. If it is independent source, its symbol will be like this. And if it is dependent source, its symbol will be like this. This is the dependent symbol. dependent current source. So the dependent symbol is like this. It may be current, or if positive negative is put here, it will be a voltage source. If positive and negative is put here, it will be voltage source. So just for separation of dependent and independent sources, two type of symbol is given here. This is dependent source, this is also dependent source, but this is independent source. The law governing for the circuit will be different for dependent source, and it will be different for independent source. So this is independent source. Independent source means if we consider this is a resistance and this is current. Suppose I take independent source, current source means any value of voltage, any value of voltage is drawn by load, the value of current I does not change. Does not change. Then it is called independent current source. Independent current source. Suppose here, if we take the example, suppose current is, let current I equal to, here I am taking example, suppose I equal to 10 ampere, and I am changing this resistance here. This is a symbol for variable resistance, and at this time suppose resistance is 10 ohm. So voltage as per Ohm's law, I into R. I told you I will explain everything based on the Ohm's law only. If you remember this law of V equal to I into R, it will be very, very easy to understand the all circuits solving problems that we will discuss in later coming lectures. So from Ohm's law, V equal to I into R, how much V? I is 10 multiplied by resistance is 10. So voltage is 100 volt. If I change this resistance, suppose resistance is now this resistance is changed to 20 ohm. So what will be the voltage V1? Now voltage will be I into R, again from Ohm's law. I is 10 and resistance is 20. So voltage becomes 200 volt. Means by changing this resistance, the voltage across this resistance is changing. But the value of current is not changing. So this type of source is called independent source. Means whatever voltage we can draw, the value of current does not change. So this type of source is called independent current source. And in same way, this is symbol of independent voltage source. In the case of independent voltage source, what we can do in the case of independent voltage source, here again we connect the load resistance that is given by R, and suppose if there is a voltage V applied is here, let it is 10 volt for example, or 100 volt, and the resistance is here, suppose it is at the time 10 ohm. So what will be the value of current from Ohm's law? I equal to V by R. So V is here 100 and resistance is 10, so it will be 10 ampere. So current is here 10 ampere if resistance is 10 ohm. But when resistance is changed, suppose now resistance is changed to 20 ohm. So what will be the value of new current? New current will, the voltage is still again voltage is here 100 volt, 100 divided by 20. So current is 5 ampere. If resistance is reduced, suppose the resistance is 5 ohm. So what will be the value of current? The new current I2 will be from Ohm's law V by R, and V is 100 and resistance is how much? Resistance is 5. So current becomes 20 ampere. So here we can see that by changing the value of the resistance, the value of current is changing, but the value of voltage is not changing. That is why it is called independent voltage source. Means whatever current is drawn from the source, the voltage across the source remains constant, then this type of source is called independent voltage source. The independent AC source is represented like this. Here, sinusoidal shape is given. This source is DC source. These two sources are independent AC source and DC source. If we see here how many terminals are there, this is one terminal and this is another terminal. So here two terminals are there. So for independent sources, terminals will be two, one and two, one and two. Terminals will be only two. So for independent sources, symbol will be like this, and it has two terminals. And for the independent current source, how much voltage we can draw across this source, the value of current does not change. So this type of source is called independent source. Now another thing is that what is the ideal current source and what is ideal voltage source, that is also shown in the next part. But here I am writing just here what is ideal source, ideal current source. The ideal current source means, suppose this is our current source and its internal resistance which is placed in parallel with the current source. This is the current source, and its internal resistance, if its internal resistance is infinity, means very high, and we connect here a load resistance RL, then whatever value of current is coming here, it will not go here. Here current will be zero. I1 current will be zero because the resistance is infinite, so current will be zero. So whatever current is coming here, all the current will go through the load. So ideal current source has infinite resistance. The logic behind it is that if its resistance is infinite, none of the current from the source is going internal into the circuit, but whole current is going through the load. This is the definition of ideal current source. In same way, we can also write the definition for ideal voltage source. Let us see for ideal voltage source how we can write. Suppose this is our voltage source drawing here. It has also internal resistance that I put either upside or downside, does not matter. Here suppose it is internal voltage is E and this is internal resistance is R. So in this case its internal resistance is 0. So whatever voltage, suppose if this voltage is 10 volt, so we will get here 10 volt and output we will get here 10 volt. Because this resistance will not drop any voltage, so ideal voltage source has zero internal resistance. Means this resistance is zero. But in practical situation, it never happen that its internal resistance will be zero. In same case, in the case of the ideal current source, there will be some internal resistance. Its value may be very high, but the current also here is not zero in practical situation. Some current is drawn by this resistance also. Some voltage is also drawn by this also. So this type of source is called practical source, and this is ideal voltage source, means internal resistance is supposed to be zero. So this representation is also given here. We can see here its definition is also given here. So an ideal voltage source has zero internal resistance, so that changes in the load resistance will not change the voltage applied. Means if we change here the load resistance here, this is load resistance, by changing this load resistance, this voltage E will not change if this value is 0. If this internal resistance is 0, so the whole voltage is appearing across these two terminals. So the whole voltage will be available across the load resistance. And if this resistance has some value, then there will be a voltage drop. That internal voltage drop we can write I multiplied by this internal resistance. So this much voltage will be dropped, and supply voltage is E here. So the load voltage that will be available at this terminal A and B, if I can write VAB, then it will be E, that is applied voltage, minus I into R. I is the current flowing here, that current will go here, the same current will go here. So if it has some value, then we will not get here the full voltage, applied voltage. Some drop will take place due to this resistance. But if this value of resistance R is 0, if it is 0, then VAB will be equal to E, means whatever voltage we are giving here as a source, that will appear across the load. But if R has some value, then all voltage will not appear across the load. That is why the internal resistance is assumed to be 0 for an ideal voltage source. In same way, an ideal current source has infinite internal resistance. Suppose this resistance is infinite, so whatever current is coming, and if we connect a load here, suppose if we connect a load here, RL is the load. So whatever current is coming here, it will go through this path. It will not go through this path because it has infinite value. So ideal current source has infinite resistance, such that whatever the source current, it has to go from this to has to go from here to the load resistance. Now a source may be represented either as a current source or a voltage source. Both have same meaning. A sources can be represented as voltage source or current source. The two type of representation have the same resistance and are related by the above relation. So we can like E equal to I multiplied by R, we can write current multiplied from Ohm's law. So a source can be represented by voltage source or it can be represented by current source. So from here current will be E by R. So this is a current source and this is a voltage source. It is just a two different type of representation, but the meaning of both is same. Energy source is there, current source or voltage source. Now, as I told in the beginning of this lecture, so there are dependent sources. That dependent sources, if we see here, its symbol is different than the independent sources. We can very easily see that this is a plus minus and its shape is like this. So it is a voltage dependent. It is a voltage dependent voltage. So this is a current controlled voltage source. Means this voltage source is being controlled by somewhere through the current. That is why it is called current controlled voltage source. The source is voltage, but it is being controlled by somewhere by the current. So this source, if I change this current, suppose if I write this type of equation, suppose if I write here like Ix and this is another, I'm just writing for example to understand, this is the value, this is plus minus Ix into suppose I write 5 here. So if I change Ix from this side, the value of voltage will change here. So this type of this is called current controlled voltage source. This is a voltage source, but it is controlled by current. In this way, there are four type of dependent source. One is voltage controlled voltage source, current controlled current source, voltage current controlled voltage source, voltage controlled current source. So dependent source will be four types. Means the voltage here, in this case, voltage is controlled by current. This is the example. Voltage is controlled by the current. So there are four types of dependent sources that we will also study in different type of circuit. But for symbolical representation, I had given it here. So, okay, thank you very much. So this representation, this is a voltage controlled voltage source. This is voltage controlled voltage source. This is voltage controlled voltage source, means this voltage is controlled somewhere in the circuit. Like if I see here, this is a voltage source, here some voltage is there, that voltage is controlled by some, this is a controlling voltage, it is being controlled, so here voltage will also change. VDN is the voltage from here to here. So if I change this voltage from here, the voltage will be changed also here. That is why this is called voltage dependent voltage source, because its voltage is depending on voltage somewhere in the circuit. So this is called voltage dependent voltage source. If we see here, this is the example of controlling current. If I change current here, here voltage will change. So thus this type of source is called voltage. This is a dependent source. So this voltage is depending on current. So voltage dependent current source means voltage. This is a voltage source, but depending on current. So this is called voltage dependent current source. Here this is a source of, this is called also, this another name is current controlled current source. Current controlled voltage source means this is a voltage source and it is controlled by this current Ix. This Ix is somewhere in the circuit. So this, it has two terminal here and two terminal. If I see this example, two terminal is here and two terminals are here. So dependent source has four terminals. Dependent source has four terminals, but dependent source has how much? Two terminals only. Independent, this is independent voltage source, so it has only two terminals.